And we are going live. Hello. I'm going to give a few minutes if anyone wants to hop into chat before I actually begin working. I've had a bit of free time today, and I've been thinking a lot about this printer project because this data storage system that I built last stream has had a lot of issues. It just does not work well. Let me see. It says the stream is doing well. Let me check on this. So I realized I forgot to change a setting before I began streaming. Hopefully we don't have that many issues. We'll be getting ready to rebuild this. The main thing I want to work on is actually making it a lot more reliable and a lot more accurate. My goal is to actually use a system with controlled bearings this time instead of pulsing pistons to actually get the print head to move. Because for some reason, the pistons extend and retract at different rates. So it's smooth when it comes back, it is not smooth when it extends. And for that reason, I want to do a quick little experiment with bearing. I want to use the weaker pistons because the pistons are going to be here just to basically transport a connection signal, and that's about it for this design. And then on the end of this, I want to do yes, it is magma. Hello. Parts. I want the one that has all six or whatever sides. And then oh, it's so satisfying when you actually get all of them to spin like that. Not right now, not in Scrap Mechanic. I'm going to be doing some testing. Not exactly what I was expecting. I might only do one of these. So for now, I'm just going to set this to 0. And this is going to do 90-degree steps. And I want to set this to loop and fast. So it'll always go to... I am building the 3D printer Mark II. This was the latest data design that I was working on. Essentially, this down here has a location like marker that tells the print head where it's currently at. This is the actual data up here. So I could say I want it to go to position 4. And then there'd be a start button. And it'll try and move to position 4. So this is 0, 1, 2, 3, 4. It is where it should be. And then it should send data. However, it has scanned the wrong one. That's the problem. Is because this print head is a little jittery because I'm using pulsing pistons, it doesn't always get a good reading. And in this case, it looks like it scanned position 1 for some reason. But if I do it again, it scanned position. No, this is 4. It did scan correctly. I've discovered that pistons extend and retract at different rates. Um, so because they extend faster, this system becomes a lot less reliable when it's scanning a higher number than where the head is at. If it's scanning a lower number, let's say we do 2. It usually gets this correct. See how like smooth that head motion was? And there we go. It scanned 2 correctly. Nope, didn't even scan it correctly. It's got a fucking extra bit on it. That's not supposed to be on. That's the problem with the current data device, is it's just unreliable. So we're going to try and do something a lot more reliable. For that, we are going to do up a system where this will hopefully, I'm going to try these. These might be a bit smaller. No. Too big. So now, if I press this button, I want this to go the other direction. Let me see if I put this on a lift. It immediately fucking breaks. Okay. Now if I press this, even though the pistons themselves don't have anything on them, I can move the head. And I'm going to set this, instead of 90, it's going to be 45. Now use this to index the scan head. I'm going to be playing more Gearblocks. I didn't stop because of the community. I stopped just because I've moved twice since like the last time I did any major content. Yes. Also, like, I've been working. I'm surprise, surprise. The person who enjoys this is becoming an electrician. I'm currently in an apprenticeship program, actually learning proper stuff. Like, I'm currently working on a hospital that's being built in the local area. Also got married. My husband's laying in bed beside me. They're in the same room as me. You might hear them in the background at some point. So here's what I'm gonna do. I'm actually gonna get rid of the ones on this, and then I'm gonna put a second controller. So instead of this one controlling that, I'm gonna have this one controlling that, and this one's gonna be at positive. So now I should be able to drive this forward and put this on loop and reverse. Oh, it's still set to slow. Fast. So if I do this, now that's there. If I hold this, now that's here. I would like there to be a little less wiggle room. And now it's here. there. This is what I want to avoid right here. There's a little too much wiggle room for my liking. So what I might do, I'm curious if I can turn these, instead of them being round, just drive this forward. Oh. This goes back 45 and then starts 45. Yeah. Can I do these instead? Or is that going to bind too much? That was not what I was trying to delete. So if I push that 45, I can't, real quick, just send this away. Yeah, there's the problem. So now it wants to lift. If I oh, what? Oh, because I'm using the weakest piston. That's why. It does lift itself up a little bit. It does seem to index itself really well. Curious. Let's see. I want to try a few different sizes. Of like round objects. I think these might have been one of the ones that's like really perfect because it's just barely smaller. Oh, it's not gripping. Oh, because this is still being controlled. Why is it not gripping? Let me see. Is Is it just the size? Okay. No. Hmm. No. Okay, this is bouncing. Curious if I could run just a guide through here to hold this down. This just jams entirely now. Oh, and now that there's no room for vertical motion, this jams up. I'm gonna try these again. There's also these. Maybe these mesh together a lot better. And this is where we're just gonna have to force this for right now. Okay. Promise. A little bit of jamming. Okay, this is immediately showing a lot of promise. I'm not that happy with how much the head is bouncing on this. But if I do this at 45, it stops pretty darn centered. If I bring it back by 1, that's pretty darn centered. So what I want to do... This might make the print head a little bit slower, but I don't care if it makes it more reliable. Grab bearing. Let's put this on a lift. Actually, let's make it so it doesn't start. Yep. Could do. I'm gonna do interactive parts. I'm gonna move where these are located real quick. Now, every time I go 1, I'm just going to do this. I'm actually going to move that. So it moves, tells it it's moved. Moves, tells it it's moved. Moves, tells it it's moved. The small straight pipe pieces? Are you talking about these? That's not as centered as it was before. And that is very much not centered. So no, that's not going to work for what I want it to do. Let me do and navigate. This is this way. This goes this way. Let's do 2 of our. So if I tap this, why does it try and move both of them at the same time? Okay. Now if I tap this, every time I tap it, it will move one space. Or I can just hold it. But as soon as I let go, I think this is our new control mechanism. is this can hold a print head. I can either use this just as the guide, or I could attach the print head. In my experience, piston memory is a little bit easier to work with. That's the reason I'm using it. Logic memory, if you don't send it the correct signal, it can jam up, and if it jams, everything breaks. With piston memory, if it jams up, you get 1 or 2 bad signals, and then it fixes itself. It's a lot more reliable in my experience. That's why I use piston memory. So what I want to do is I want to do this on a massive scale. I want to put the print head, I think, or the read head on this system. I still want to use like the old USB style that I did. I don't. I want the print head to move inside, or the read head. I keep saying print head. Well, it's not just like Vicky. Have you seen my old 3D printer? Shits and giggles. Oh, the frame rate. So we're working on the V2 of this thing today. Is it just going? Let's change that. Hard reset. Um, so this is the old print, or the old data device. Essentially inside this, a little read head slides along, reading the binary that's written on top. It then can transmit those signals in between this pin connector. So the whole idea is you just take this USB off, switch it out, and run a different print entirely. In this case, I think I've booted her up properly. The problem with this design is it is so slow. It is unbelievably slow. Like, this is its print speed. There's a time lapse that is on the channel. Oh yeah, it just jammed up there. Oh yep, something fucked. There's a time lapse on the channel of this working and doing the full print to completion. It's printing a Benchy right now. The problem is this system that I'm using for scanning is so wobbly that actually reading this much data takes so long because you're waiting for this printhead to stop, because this printhead shakes violently when this is moving, which is also the same reason that failed to print that block there. Yeah, she's breaking. I did something wrong. Let's hold this, reset. I kind of want to turn this on just so that it can go in the background, because I think that'd be funny for the stream. Hello. Let me see, is this the hard reset? One of these is a hard reset. I haven't touched this project in years. Oops. Let's see if the machine should be ready. I'm just gonna hit this green button. Yeah, I built this thing forever ago. To configure different USBs to print different stuff, you just come up here and paint the black dots. The black dots are ones, whereas the colors you see are zeros. The colors are just there to help me when I programmed. And then these segments of 3, each segment of 3 is a new command. So this reads command coordinate loop. So what's the command? Where's the command being processed? How many times are you processing that command? And that's what all those black dots are. They're just a bunch of data that the printer reads. You can see, like, I put purple. That was, I think I was debugging this. So that's what the purple is. It was just marking it. Because black is the only thing this cares about. The colors, it just ignores. The colors it sees as basically anything else. I'm going to casually let this run in the background for now, while we continue to work on this prototype. So this is designed to be the new USB device for me to store data on, because that was the major factor that was slowing this down. This one, if it prints properly, will print a Benchy. So this, I think, so this is the model someone sent me. While I was streaming the last one, this is what it will print. With some minor modifications, like that slot isn't there, and this is a little shallower. Because one of the limitations I ran into was just how much data can be stored and um, how large the commands are. With this, each command is 3 sections of 8. So what? Each command's 3 bytes of data. But within those 3 bytes, I could print an entire layer, as long as it's solid. Um, yeah, I think there was a misprint there. Oh well, I'm just gonna let this run. No, no, that's not a misprint. It is actually in the original model. Okay. We're just gonna let that run in the background for fun. That's reverse. This is forward. And what I want to do is put the actual read heads here. Just because I can. I'm still very proud of this design. So here's what the USB looks like. The actual logic in it. And here's the printer. A lot of like memory / counting cells. And then this is the actual. This right here is the actual code loop that goes through. This has the ability to draw vertical, horizontal, and diagonal lines, as well as draw squares in 2 materials. So I can draw in blocks or glass. Glass is used as like a support material. Um, and that allows me to do like hollow spaces and stuff. Then what I can do with this, I'm going to use the same low friction just in case there is any weight on this head. This one is going to be a block above anyway. So I'm just making this big so I can prototype. Once I get like the logic and sound. Yeah, this is an 8-bit computer, basically. This is actually reading binary and executing commands based off that binary. And you can see the actual bottom layer of the boat is printed. Now it's printing a support layer over it. This will take like an hour. It's like an hour and 45 minutes to print. So the length of this stream, it'll probably be done. Range 2, color mode, black. And if I tell it go forward, the what? The DFST. Which generation was that? Yes, I do believe that I was the creator of the DFST, the downfiring cannons. Let me see DFST if I have one saved. These were yes, these were something I designed. This is I think one of the auto loading ones. Um, I think I had experimented with instead of using bearings, using the pistons to mount rounds to, and I had noticed some weird physics where it would try and extend the piston even when the block it was attached to broke, which imparted a level of force to the round. After some experimentation, I realized the game would always give the physics to the larger object. So when you're using just a little elbow like this, the physics will always be attached to the bomb because the bomb has more mass. So this doesn't get the same uh, physics transfer because as soon as the block is broken, this loses all momentum. But the bomb has the larger mass, so the game imports the physics to it. This, what I'm building now, is a logic check to see which number is higher. Right now, I'm telling it to go to 0, 0. Current head says it's there. So this is the one that needs to go down. So this would go to this far one. So go to this one. And then, if these all equal, I want to make sure I grab this. Here in a moment, I'm going to have to take a break, an intermission, to use the restroom. So now if I hit this button, it should return to 1. Oh. Why? Oh, because you're hitting the restarts. I don't want you to hit the restarts. There we go. I want you to be the sole controller of the restart. I don't need these to be ands. I want these to be XNORs. There we go. So if I send it to this, And now I'm going to send it to this one. It works. It works. Oh, good. This is 0. So 0. 2, 3. If I send it to 0, made no sound. Will you make sound? It is getting like 1 tick pulses. So if I send it to So there is unfortunately no new cannons coming. This is nice. Because if I'm doing any tank stuff, I'm probably gonna do it in Stormworks. Oh, this is great. This is perfect. Now then, I want to make this much bigger. So let's actually start working on the proper prototype. Um, we have 16, 32. Wish there was a better low friction brick block than this. I'm going to run to the restroom real quick. I'm going to take a brief intermission, and I will be right back. And I'm back. And this is printing pretty nicely. Let's return to what we were working on. Go. There's 128 bytes data storage here. And do is I could have done this when I was welding this up. So the head's going to start here, work its way down. I did a little bit in high school. A lot of this is self-taught. Now, each piston can extend 15 blocks. We're doing 128, so we need 10 pistons, I believe. 9? 90. No, we can get away with 9. 8. Can we get away with 8? 80. No, we need 9. We need 9 pistons. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 pistons. I said 8 or 9. So Do interactive. Neighbor's dog is barking. He's loud. He's probably in the hallway. I'm not worried about it right now. I realize these are gonna have to come out another block. Because I'm gonna have to do 2. Yeah, I wish I'd done something for duplicating it. 1, 2, 3, 4, 5, 6. Eight. This is where the actual sensors are going to be. And really quick. 3D V2 USB temp. Starting to get to that point where it's lagging. Just gonna steal this controller to test. It's a larger one. Set these as color reading as well. So in theory, if I tell it to go here, this is immediately jamming. Okay. Here's what we're going to do. We're going to pop that. It's just going to keep running. It's going to just keep trying to succeed. Now, let's push it to its extreme and send it to the very end. Now, when using the actual 3D printer, it shouldn't be moving from the start to the end in one long go. It should just be moving to the next bit. Theoretically, yes, I would want these low friction. Right now, I don't care. That's not good. Also not sure why they're raising up so much. That's it. It's supposed to be like that. This doesn't explode during this test. I might call this fine. Stream seems like it's suffering a little bit. Make sure Steam's not trying to download something. Okay, we're about halfway done and it seems okay. If it survives this, I'm going to compact that down. It's one of the newer models. Yeah, 2018. Oh, something jammed. Is it struggling? He's fully extended? Am I mathing correctly? Yeah, the 16 extension, or 15 extension. Oh, is this not 128? One, two, 4, 8, 16, 32, 128, 250. Oh, I need 20 pistons instead of 10. I can store twice the amount of data I thought I could. Oops. Let me see. Let me do some math real quick. 256 divided by 15. I need 17. I need 18 pistons. I only have 10. So this is as far as it'll ever go. That just exploded. Since this already uses such a wide space, I'm actually just gonna double it this way. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10. It's actually more than I plan to put in here. 11, 12, 13, 14, 15, 16, 17, 18. And I'm going to take this opportunity to do this too. It's stopping me from putting it here. Oh, okay. I don't mess with glitch welding. I never really have. I've done a little bit with it, but it was more so like, oh, this is kind of cool, and then we used it for cannons, like some spud based cannons. But ever since then, I try and avoid a lot of it when I can, where I can. We'll let this run. I'm happy with how much this is vibrating right now. Might try and stabilize this. Engines? Are you talking about like piston engines, or is there a different type? And experimenting again with like the spud gun engines. I think that'd be kind of fun. Oh, that just exploded. I don't like how the experience side of SM just thinks that entirely the standard should be kept. No. It does seem to have fixed itself, though. It may have exploded because I'm messing with it. Yay! If I do... Yeah, it's not supposed to happen. Okay. I have one of these rotations slipped. I'll have a good one, Trek. Let's see. Once this gets caught up, could always put it on the lift. De-weld it. Oh, frame rate. That broke it even harder. We need to put the pulling rod on both sides to stabilize it. That's new. Hmm. VR. That's kind of how my last one was working. Oh, so this one over here has just been chugging away. Dang it's. Okay. I don't want to do a fully logic based because then I might have to have like 1,000 sensors. I don't think the game can handle that. I'm trying to think of what else. With the old one, one sensor moved a block. It was like a binary sequence. A sensor moved one block, another one moved two, another one moved four, another one moved eight, and you would just turn on and off a stack of pistons depending on which number you needed. You would literally just send a binary sequence to these. But that's where the print head would wobble really badly. I have another idea in mind. Instead of making the print head move, I can actually move the data like it's a card, like it's a punch card. I didn't want to do that because that's a lot of weight to be throwing around and moving. I was just going to make the print head move. But the print head has to transfer data, whereas the card doesn't need to transfer its own data. It can just read its own data, if that makes sense. So, next plan. Because the card can lay in here with no support. I've seen another data storage that someone else did. I forget what the project was for. But it was effectively like, how do I describe? Basically, it was all cardboard, and then the system would save it. It would just destroy the cardboard and then save it. Oh. Ew, I'm gonna be here for quite a bit. I'm going to take the controller off this. So this I'm going to just consider a failure. I forgot that the new wedges exist. That's why I'm not using them. I have no clue. Should have an auto clicker. There it is. Okay, so I can't just push this in here. I thought I could like lift and lower the print. Try something. Really? Really? here. This can go under it. Huh. Let me see. Two, three, 4, 5, 6, 7, 8. I made this one too wide. Yeah, it may have been a miscalculation there. Then I'd have to have a lot of sensors. I could, in theory, do it, but I don't feel like it. I'd rather it be much easier to draw the data. And we can attach this controller. For the time being. I actually need a hammer. This is going to be a minor issue. I'm just going to go ahead and delete this. This is all legacy stuff. V2, I want to first off improve the speed. That's what I'm focusing on here because the thing that slowed down the V1 so much was the fact that I was using um, a really bad data storage system. That's what slowed down the V1 so much. Um, on top of that, uh, I want to go from a 16 by 16 by 16 to a 32 by 32 by 32. Just because it can in some part. Also because the the end goal is to also improve the data storage, like the actual size of the commands, because the old ones, the commands were 3 bits, or 3 bytes, which is a lot of wasted data, basically. Um, Also, on this, I'm gonna have to put like some dead pixels. List for the system to push the USB in and out. So it's like speed, print size. I want to redo the programming language as well. Those are like the 3 things that I'm aware that I want to fix. Um, Oh, and I want to add a function command or a pattern command. Because right now the old printer can do vertical line, horizontal line, diagonal line. I want it to also be, and it can do squares. But the new one, I want to be able to draw patterns. So, spoilers, I'm intending the printer to run 3 separate USB devices. Are you not allowed to go back 2 minutes? Oh. Um, eventually, I want to have the printer running 3 different USB devices. Um, the main device will actually run the command, whereas the other 2 USBs will store the patterns. So you can input custom patterns. No. Curious.
That's the only thing I'm interested in.
For $50, yeah. Um, husband sent me a Facebook post with some old cameras, including one of the cameras we collect. We collect Polaroids.
Specifically SX70.
Yes, an old what Model 1 SX70?
What model it
Yeah,
is.
it's a Model 1. Um, so eventually I want the printer to run 3 separate USBs. One of which will be the actual main command. The other two will be um, print or patterns, basically. And with those patterns, I want to make some like pre-programmed patterns, like draw circle. However, if you really want to go deep into this, you could, in theory, run a like draw anything pattern. So this one just failed. Spectacularly, in fact. It exploded. Alright. Oh, I've encountered so many bugs, including this one. Cool. I don't know what YouTube's done. Was it about the question of like what's the new printer supposed to add? I can answer that again if you want me to. The stream may have like dropped out for a second and restarted, and that's why YouTube's doing it. Because there is a setting I forgot to change on my internet connection that helps me streaming. I forgot to check that, but if I check it now, I have to restart my internet. Okay, so the the improvements I want to make with the Mark II. One, I want to make the system run a whole lot faster. The main reason I'm spending so much time on this USB device is the old USB device is what caused a lot of the time waste. Um, the print head in the old USB was very finicky and would shake a lot, um, which meant that you had to wait like 10 or 15 seconds every command you put in so that the read head could stop vibrating long enough to read the command safely. Um, so every command took like 10, 15 seconds to read. And then just the same thing happens with the printhead because the printhead's using the same system, same like technology, I guess. It vibrates a lot. So I had to slow the clock speed down because of the unreliability of my motor controller, basically. Um, as a result, this thing can be very slow printing. So I don't know what this is doing. Yeah, it messed up somewhere. Yeah, this one's bugged. It's probably because I was lagging the system out. So I want to improve the USB to make the system faster. I want to increase it from 16 by 16 by 16 build space to 32 by 32 by 32 build space. I want to be able to accomplish that by improving the command sizes. Because with the original printer, every command was 3 bytes long. I think I've discovered a way that I can compact the actual code down to about 1 byte per like major command. However, in doing so, I'm gonna have to add some specialty commands in there for like changing out the print material and so on and so forth. So the majority of print commands will be 1 byte long. However, if I need to change a variable, I'll have it like 2 or 3 bytes long. At which point it's the same size as the old code. In theory, um, I should like double or triple the amount of data I can store on a USB with this new programming that I'm trying to do. So faster, bigger build space, better programming. Um, I also want to do like a draw pattern command because the old printer could do vertical, horizontal, diagonal lines, squares, and that was it. I want to be able to do vertical, horizontal, diagonal lines, squares, and purpose built patterns. So the device is going to have 3 USBs instead of 1 USB. One USB is just going to be the actual commands, whereas the other 2 USBs I want to be, um, I want to have some pre-builts for like draw circle, but I want to also make them interlocking so that if you want to print something really, really big, you can essentially link all 3 USBs together to use what 256 times 3, like 1,000, like a fucking like megabyte or something like that. Essentially, this new printer will have like 3 times the data storage as the old printers. What I'm referring to as USB is this thing here, this big gray block. It is my data storage system. Um, on the top is drawn binary in black, and this is the code that this thing reads and executes in order to draw a 3D printed object. This is going to be a benchy. It has glitched a little bit, which honestly may be because I've been lagging the world, but this is able to read the commands, transfer them to all of this, execute those commands, done. Yeah, I'm writing the code by hand. If I see if I have one of the worlds. Yeah, there's an attempt to make the printer faster. I don't think I have it here. I could go looking for it. But essentially, someone sent me a benchy model, this, and I cut it up into slices. I figured out what the order of operations needed to be, and then I programmed each command that the print head needs to do on here by hand. And the reason I call it a USB is because it's literally linked by a single block. If I break this block, the USB can fall off, with the intent that someone could write their own code, and all they'd have to do is delete this block and switch out the actual card and print that. In theory, as well, with the new 3D printer I want to do, you could also just do like a disk 1, disk 2, disk 3 thing where you print one USB, switch it, print the second one, switch it, print the third one. You could eventually print all of it. I could color encode, but that means I would have to do um like several sensors on a single block, and then I'm literally just trying to do this 8-bit binary. If I did color encoding, I could store more data, but that's above me at the moment. I don't feel like doing it generally. Um, I need to find a better data storage method. Pulsing piston isn't working. This rotary system is a lot more reliable, but inside there's moving sensors. You can see the sensor row here. So this one worked where each set of pistons is set up to a binary number, where effectively you can put in whatever location you want to scan into this. So this moves a single piston 1 block. This moves a piston 2, 4, 8, 16, 32, 64, 128. And depending on which ones of those are turned on, it extends the head to a certain distance. It can then read that data, and then it sends it through this pin connection. It sends the data through here. Now I have an idea. This is a dumb idea, but I have an idea. Um, I read directly from the USB. Let's see. I'm trying to improve the speed of the USB read head because the USB read head is what caused a lot of the like slow printing issues. So if I can improve how fast this operates and how stable this operates, um, I can read data faster. If I can read data faster, I can run the machine at a faster clock rate. I've experimented with logic memory, and I may end up having to do that. It's just complicated. And uh, I've done I've done logic based memory like this. This is a full logic base. It does have and you print it on the top. But once you have too many sensors, it also kind of freaks the game out a lot. I'm trying to store the thing is with that gene, I'm trying to store I think like a megabyte at this point because I want to have 256 bytes times 3. So what's that? Here 256 times 3. Um no, it's not quite a megabyte. 200, 268 bytes. Yeah, 200. All right, no, not two. 700. Almost a kilobyte of data storage is what I'm aiming for. This might be what I have to go to. So I might have to go to logic based. Do you read the USB in the same order every time? In this case, yes. However, if I'm adding the draw pattern function, no. So I need to be able to jump to a specific location in the dataset. Um, and actually, this can actually do that. So what this logic is doing is it's saying I want to go to this position. It compares where the printhead is at, so it reads a like barcode on the bottom of the USB to see where the head's at. This tells it where the head needs to be. It decides if the head needs to move forward or backwards, and it then does that until the print head or the head reads that it's at the location it should be at. I think I'm going to have to just go to a fully logic based USB for this one, especially with how much data I want to pump as fast as I am. The mechanism will be the same as if I was doing physical. The original USB was logic. The second USB, which is the one that's working on that there, is pistons. Um, that are set in a binary sequence. I've tried pulsing pistons, but those are not accurate enough. I've tried gears, which is what this design was, and it's too flimsy and it's broken too many times. So I'm probably going to just um, go to a logic based system. I'm going to experiment with that real quick. I want to use my piston logic for this, my piston save system, just because I found it more reliable. So with this, I'm essentially going to do the same thing where I will have a bunch of sensors that read location data. If I do color coding, I could, but then I have to add several sensors to a block. And then programming would be such a pain in the butt. Oh, I'm going to say no to doing color coding. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, 8. Logic. Um, I might try and do encoding, pulse encoding. 2 moments. Um, so pulse encoding. Effectively, the idea is you can send multiple. So I'm gonna have to send a decent chunk of data, and I don't feel like making 35 connections for every like. Not I say 35 is just a random number. I'm gonna try and do pulse encoding. So I can send large amounts of data with less connections just for the USB. Because God, if I do a full logic USB, that's a lot of connections. So now I pulse this. It's I'm not gonna be doing it logic, but it's gonna be using sensors as reference. So I can paint it. To color mode on black. Color mode on black. Um, I my anticipation is to actually build. I could just send it through a pulse, but what I'm actually planning to do is have the USB decode itself, and then just send a binary signal across the connector like that one. So in theory, I could make this USB backwards compatible. this up.
Right, show me all your nerd shit. What you doing?
The pulse thing. So what's going on here is as I press either of these buttons, this is going to create a 1-tick pulse. This is going to be sent out here. This will take that 1 tick and just basically check if this is on. So this is the clock. This will always pulse here. This will check each one of these one by one. So in this case, and then send them up into this rail, which comes over here. So if I were to paint this in a pulsing pattern, first you'll get the clock, and then you'll get the pulse. Think of it like sending Morse code.
I'll say I definitely understand any of this.
And then I'm going to have a decoder that's going to see the first pulse, treat that as clock. The Fant tool. I don't use mods a lot.
Oh, this is all vanilla, baby. This is just pure insanity.
Yes, pure insanity.
How many days do you think you're gonna work on this one?
I don't know. So real quick, if I do this,
I just noticed the long thing you have in the background. Yeah, what the hell is that?
The 3D printer Mark 1. I'm making the 3D printer Mark 2.
Hey, have fun.
Yes.
Don't go too crazy. Food.
Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is gonna go into here. I'm actually gonna put Can I do it? It's gonna have ands. This one doesn't need an and because this is actually gonna be And now I'm just going to use the like that. Okay, this is too slow. This is a memory block, but it itself is too slow for this pulse system that I'm trying to do. Oh, you can see it. I think I have it. There you go. This pulse system can transfer 8 bits through a single logic connection. Oh, I'm so happy with that. Okay, just to make sure I'm not like losing my sanity. Yes, I think so.
I think so. It's gonna break in 2 seconds.
Yes. Okay. Okay. So now, not only should I be able to do this, I should be able to send. I'm planning to use pistons. That's what I'd like to do. And then if I did pulse generator data transfer pulse. Apparently, I have a pulse generator for something. Data transfer pulse generator. Basically, I'm gonna have this come out here. This is reading it. This is reading the individual bytes right now. And then those are just gonna get jammed into a memory circuit, and saved, so that they can just extend the pistons. This is a big USB device. What I want to do is connect this. So I don't need this pulse generator. I don't need this pulse generator. What I can do is on this one, uh, and if I pulse receiver, pulse receiver, I can cut this off. Oh, we're starting to get to an actual a pulse that's long enough. Which case, that's not even correct. Here, I'm just gonna do this. Then I'm also gonna try and read like head position. In theory, you could read the whole USB like this. So what we want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 17. 17 ticks a delay. I'm just gonna have first and last bits be data. Oh, I guess this is the last bit, isn't it? There we go. Normally pistons can run one tick. The problem was the logic in my old memory bit was seeing every single pulse come through. So now, if I do, say, just a random sequence. So here's the top one. That's looking correct. Here. I'm going to do purple and light blue. No. So this is the top section, and this is the bottom section. We're doing 8-bit. The only reason I have 16 here is because I'm also going to run a it's going to check where the data's or it's reading data from. That's all it's doing. It's just checking where the like read head is at, quote unquote. So in the same way, like I have a binary sequence written on this to check where the head's at. Okay. Here's what I want to do. I want to do this so I can delete these. Okay. And then I want to put a I do spud logic or spud memory. I'm gonna do piston memory. Do color mode red. Piston. It's not piston. What? This. Switch mode. V.2 data slice. Data slice. So if I send and first I send this to turn this on. And then if I do and nor, just gonna do this real quick. If I set it, I can move it forward and backwards. Yeah, they're essentially a flip-flop. I'm just using them for memory. Now, I can do a change these to and. Run this down. If I do a read signal, I can get another read signal. Enhance this. Now attach the decoder to it. So for this, I want to do 0, 1, 2, 3. And then on the actual data storage, I'm just going to go 1, 2, 3, 4. So if I set the first one, I should see. Oh, I have to actually connect the data pulse out. Where's the top? Oh, this is 0, and then that's 2. So then if I advance it, I should see 1. There's 1. And then these 3 light up. Yes! Once you need to access a certain location without the counter. So what this is going to do is I can move this up and down. Since it reads out the location of that memory bit here, I can check it where the counter is located, and then I can just count up however many times I need to, or count down however many times I need to. For the USB itself, not particularly. Because it should only really be moving one at a time. The exception being the draw function, that's going to have to move a couple locations at a time, but it's only going to do that like 4 or 5 times in a program. Um, for the most part, it's going to move incrementally. If it needs to move large spaces, I don't care if it counts. I I could make it move directly where it needs to be, but that's a lot of logic. It's a lot of logic I don't feel like figuring out right now. V.2 pulse gen X4. X4. It's pumps. So I'm using the pumps to place blocks down. And I'm using two materials. I'm using, in this case, plastic and glass. Um, Glass acting as a support. This one's done. It had a printing issue here up front. But there's a Benchy. Actually, something to do. So the old printer had code in 3 bytes. The first was the command, the second was the XY coordinate, and the third was the amount of times that command would be repeated. So draw line starting at this coordinate that is like 5 long. I am going to try and make that a little bit smaller. And in theory, make it more similar to modern G code, where it's going to have like from whatever location the head is at, draw a line diagonally, like draw a line vertically up that is like 5 long or something like that. Um, so in theory, if what I'm thinking works, I can just send the print head um, to it, like instead of giving it a coordinate that needs to move to, I could just tell it move up 5, right 4, or whatever. So if I do need to move it to a specific coordinate, I can do so within 2 lines of code instead of 3. And then if I'm drawing like a continuous shape with different diagonals and stuff, instead of using 3 every time I change the head's direction, I can just use 1 line. Yes, relative direction, I guess, would be correct. I don't know the exact term for it. 8, 16. Oh, oh, yeah. I need to make sure these are set up. Oh, you're not connected. How did you get connected to something? What? And then decoder. Oh, I can only move this so fast. I can't spam it as much as I'd like to. Real quick, though. Now I can just move it a single, or if I really want to. I'm not sure if I can give it like a velocity or a specific vector. That's getting chunky. Oh, the frame. Break something? Did I break the sensors? Excuse me. Hello? Game. I don't think it's the pistons. And there it goes. Oh. Now I get to do this a million times. I also realized I have made a mistake. I need a clear command for these. Okay. The pulse system functions fucking perfectly. Um, the actual indexing system is where it's failing. Yep, there it goes. I'm probably going to have to change this to a logic index now. I don't wanna. Oh, also, is this not working anymore? Excuse me? I'm just not seeing it. There's not visually updating because there's so many that are. Okay. So the pulse is coming through. It's just being visually buggy. That shows it at what? That's fucking 1, 2, 4, 4, 5, 6, 7. So it's 0, 1, 2, 3, 4, 5, 6. Okay, 7. And if I do one more, this will show up as 8. Yep. Okay. Cool. This is still working. It was just visually bugged. One of you not set to. He's like right here. Okay. I want to see something. So I see where it's failing and why. And if it's repeating, this time it failed like down here. You may have to make this counter or logically instead of physically. Okay, it failed. Okay, we're at that one. Is it just an inconsistency thing? Seven past this, so 1, 2, 3, 4, 5, 6, 7. This is the one it failed on. Yeah. Because we're not even like halfway to the size we want this USB to be. Okay, this time I just finished. Okay, so it's just inconsistency. It's just broken. Okay, cool. Alright, back to the drawing board. Also, grab holes. Data slice. No, I don't have a self-wired XOR. Two state on off, yes. I want to have a toggle in here as well. Yeah, no, I need to make one tick gen. I'm just at this point, I'm really tempted to just do Spud. Not. Just here. Doing XORs like this, and then what does this do? That'll make a pulse. Okay. So if I send a reset pulse, it'll only pulse if this. And then I can do an and not. I have set reset. So if this is on and I receive a pulse, pulse this. If this is on, this is not on, and I receive a pulse, pulse this. And this just pulses this. I'm gonna put these all as ors. Actually bury the block under it. So this and this pulse. If this just pulse. If this and not, so these should be red, green, blue. Red will always turn it off. Always off. Always off. Green will always on. Blue will toggle. Always on. Red always off. Blue toggles. Eh. And then on the toggle, I add a forward and reverse so that if this and this toggle, toggle, I don't care about the size of the USB. I'd rather make it easier for me to program than anything else. I'll pull this out. And this one's fine down here. Um, and these are going to be the ones that if green I'm gonna move the blue pulse. Now, if I go forward, I go to this one. Backward, I go to this one. So I can now set this. Seems to be or. Oh, because these don't have anything to go to yet. Um, needs a... Yeah. These are also going to go straight up. On what? The USB or the printer in general? The last one took me like 3 days to do. Each one was like an 8-hour stream. I don't have that kind of time. I don't know how long this is going to take me. I'm already on my second stream. And I haven't even gotten the USB working. Something. I want to see if this is actually pulsing out. I'm going to be streaming. I might be streaming something else. I haven't really touched Stormworks in a bit. I have been wanting to get back into like the tank side of stuff there. Give me a second, I'll be right back. Turn. Something here is lagging. It's probably this. I'm gonna just delete this. My frame rate is dying. So the reason I disappeared is because my husband got stuck in the tub. Okay, set this. Move forward. Move back. And then these are set up so that when I do this, it reads out all of these. Whichever one it has selected. So what? This is 8 times 2. This is 16. I'm going to set this like 16 ticks. There, you can see the actual data transfer. And if I grab the decoder, which should be laying somewhere around here, I may have deleted it. Decoder. Oh, no data decoder. Pulse decoder? Oh. Yeah. Pulse receiver. Something here is lagging. The 256 pistons breathing down your neck. I'm gonna give this stream like 30 more minutes. We kind of end it there. I have been going for close to 5 hours, I think. So I want to try and get this functional. But if it fails again, I'll just pick back up on like a hard logic USB system later. This. Here. Data encoder. I'm just gonna 16 ticks. Since this isn't encoded yet, I'm gonna do like I did last time. think I've got this worked out. Now if I do okay, this should be correct. Pulse decoder X16. Have a good one. Now I also have the ability to hard reset, which is going to be necessary for the draw pattern command. Two, three. Part. Yes. Put these two well together. Do is I put master reset, master set. Shouldn't need a master set. Yeah, I'm gonna get rid of the master set because I shouldn't need a master set. Master reset. Give a master pulse. I give these forward and reverses. these, instead of needing to go to all of them, let's go to green and red. These put a pulse. And I'll go ahead and put the pulse up here too. And I can set it, drag it down, and then read it. One thing I am going to do though, I'm also going to add in a light indicator. Just tells me where the data is at currently, just for debugging. Can't fit here. It was not intended, but I will be happy to use it. And I will also give this a master reset. So I can reset, set, read, and move. I love seeing that thing pulse. That's so cool. At this point, I can connect these up. Connect these up. Connect these up. These. I can disconnect this. And the master resets. So I can set, move, read. Oh, these need to be ors, don't they? Read. Reset. Set. Move. Reset. Set. Move. Read. That's why. These need to be set as 4. So dumb. I could just add a separate counter. Cool, this USB might be much bigger than I intended it to. Okay. I'm gonna take a break here because I may be redesigning this anyway. So 3D V2 USB V2.3. Because I'm already going to be counting effectively, I could just count where the head's going to be at. Because I'm no longer working with a physical head, I'm working with a data head. A data should be consistent and trackable. I could keep using this design, and if I keep using this design, I could use a fucking 16-bit logic system. I might keep using this and make the printer 16-bit. I was not anticipating doing 16-bit, but I could. I could. I'm really proud of the data pulse system, actually being able to transmit all of that data through a encoder decoder. Pick this up here. Pull this to there. And then I just put button to here. I can set this, move it, and then read. To this tells me the head is at into so first two and then second to the last. First two, then third from last. So this and then these two, so the print head should be right there. Yay! Data is being transferred via the pulse system. I love this. Okay. This works. It's bigger than I intended it to be. And it's a little redundant for what I need it to be. So I'm going to take a break for tonight. We're going to address this again, I think next, or this Thursday coming up. I'm planning on doing another stream. We'll figure that out then. But for right now, I'm going to end it here. Thanks for stopping by. Thanks for sticking around. And until next time.